Okay, there's aren't volcanoes everywhere. Most of the Earth is solid. We have that liquid outer core, but that liquid doesn't get to the Earth's surface. It's magma is generated in the upper mantle and only in special situations. There's partial melting that can occur in the lower crust and in the upper asthenosphere, that upper mantle, and just at the base of the crust. It's going to happen where there is a decrease in pressure. That decrease in pressure promotes melting, or maybe an addition of volatiles in another plate tectonic setting, or there could be heat transferred from one hot body to another that produces melt. So three special cases where we can get magma. The first one then is that decompression melting. And this happens where we have thinning of the Earth's crust. So in this image, the top one, time one, here's the Earth's crust. It gets thinned. The thinning mechanism for thinning is rifting. So imagine continental rifting, where eventually you're going to have a divergent plate boundary. That thinning of the crust releases pressure on the lower crust and the upper mantle. It's hot down there, but it wasn't melting because it was under a lot of pressure. The decompression melting occurs when the pressure is taken off of it. It lowers the melting temperature of the rocks, and melt occurs. That melt is going to be less dense than the surrounding rock, so it's going to rise up to the surface. And that is the beginning of volcanism and magma being generated at a divergent plate boundary. This is going to happen then. Divergent plate boundaries, mid-ocean ridges, a mantle plume where the crust is thinned, and the continental rift valleys. So decompression melting. The next is flux melting. So two slides ago, we talked about volatiles. The volatile here is pretty much going to be water. So that when the oceanic crust goes down into the subduction zone, it's wet. Some of that material scrapes off in the accretionary wedge. There's a lot of sediment and water that goes down into the subduction zone. It's hot down there. Those volatiles, water essentially, are going to decrease the melting temperature of the rocks. When it gets down deep enough, hot enough, the water promotes melting. That then that magma then is going to be less dense in the surrounding rock, and it's going to rise to the surface above the subducting slab. And then that's why we have volcanoes just on the landward side or the other side of the trench. So here's the volcanic arc. There's the accretionary wedge, the subduction zone going down, melt coming up. We can also transfer a heat from one magma to another and start to partially melt the crust around, say, a mantle plume. So rising magma is going to carry that mantle heat with it. The crustal rock around it is going to get hot enough to melt that crustal rock, and then it generates magma. So here we have some mantle plume coming up, melting some of that country rock or crustal rock, and then generating